in this video we're given a force F, and we're given that it's 500. It's given 100 has a magnitude of 100 pounds, and we're asked to determine what is the x, y, and z components of this vector. So we're asked to write it in its Cartesian form. So that's our goal. We want to find fx, fy, and fz. But in this case, we weren't given the coordinate direction angles. We were given a slightly different set of angles. So what we're going to do is we're going to just use basic geometry to determine our x components and our y components. Okay, so if we look at our diagram, we can break this into a few different triangles. So we know the hypotenuse of this triangle, the lighter blue triangle, is equal to 100 pounds. So we can use trigonometry to determine the z component of our vector fz, and we can determine the adjacent component of our triangle, which we'll label as f prime. Okay? Once we have f prime and fz, we can then calculate the components of our smaller triangle, or the opposite side and the adjacent side of our smaller triangle. So if we look at the smaller triangle that has the 45-degree angle that's drawn, it's a little bit darker blue, it'll have two components. It'll have fx and it'll have fy. So if we write this as a big equation, what we can think of this as is, we think of it as f is equal to fx plus fy plus fz. But to make our lives a little bit simpler, is we can also think of fx and fy as being equal to f prime. All right, so fx plus fy is equal to the vector f prime. All right. So let's just use some basic trigonometry and solve for each of our vectors. Okay. So we know that fz, or the magnitude of fz, is going to be equal to the hypotenuse of our triangle, which is 100 pounds, times the sine of 60 degrees. Okay? Alright, so we know that the opposite over the hypotenuse must be equal to the sine of our angle, which in this case is 60 degrees. Okay, so our hypotenuse is 100 pounds. We multiply both sides by 100 pounds, and we get f of z is equal to 100 pounds times sine of 60. All right, so sine of 60 degrees is radical 3 over 2, so we get 50 times radical 3, which is equal to 86.603 pounds, which will round to 86.6 pounds. All right, so then we can also solve for f prime. So we know that f prime would be equal to 100 pounds times the cosine of 60 degrees, since f prime is the adjacent side of our triangle. The cosine of 60 degrees is just equal to a half, so we know that that's going to be equal to 100 pounds times a half is just going to be equal to 50 pounds. All right. So once we have f prime is the hypotenuse of that smaller blue triangle that's drawn on our diagram. So we can then we can solve for fx and fy using f prime. So we can say that f of x would be equal to f prime times the cosine of 45 degrees. So f prime was equal to 50 pounds. And then the cosine of 45 degrees is equal to radical 2 over 2. If we multiply all that out, we get 35.355 pounds, which we can approximate as being 35.4 pounds. And then our last component that we don't know is f of y, which we know we can solve for with f prime times the sine of 45 degrees, since it's the opposite side of that small blue triangle drawn on the diagram. And then if we do that, we end up getting 50 pounds times radical 2 over 2 again, The one thing we do have to add in this case is that we see that f of y as it's drawn on our diagram is going in along the negative y-axis, so it's important that we add a negative sign in this case. All right, so we add that negative sign and we end up getting minus 35.355 pounds, or minus 35.4 pounds. All right. So the last part of our problem, or the problem asked us to write this all in Cartesian form. So we could write the x component as being 35.4 pounds, I plus minus 35.4 pounds along the y-axis plus the 86.6 pounds along the positive z-axis. All right. So depending on the angles that you are given in the diagram, you can use either trigonometry or you can use the coordinate direction angles, which I guess is also trigonometry, to solve for the x, y, and z components. So sometimes you might have to do like this double. You might have to solve for an intermediate value like f prime, and then use that intermediate value to find your x and y components to then get the overall vector in Cartesian form. All right. And that concludes this problem on breaking down a vector into its Cartesian components with an intermediate component f prime.